Okay. Hi. I thought I would make a tutorial about LSystems because I see a lot of stuff. Basically, I've been using touchdesigner for about a year and a half, 2 years, and I've never really gotten past the initial L system. And so if you're like me, it's just because you didn't know anything about it, and you're maybe like me intimidated um, by the little text box down here that seems to have no correlation with this, and I have no idea what's going on and everything. So I figured I would learn it, and I would just give a little tutorial. And yeah, so how did I learn it? I actually watched this video here. I just searched L Systems Touch Designer, and this guy here talks about what an L system is, and talks about a very important idea, several important ideas. First off being that an L system is a set of instructions, kind of like a genetic code. It's a recursive set of instructions. So you give it an initial something, and then it will then you give it a rule. It will take that initial thing, like the letter A, and it will translate it into whatever rule you've defined. So if it's A equals ABA, as in this, then every time you find an A, you'll put ABA, and then for the next round, every time you find an A, you'll do the same thing. So what that means is when you understand this concept, and I really recommend that you watch this video, parts of it, what it means is that you understand that this little box here is actually a little set of instructions, and a set of instructions and a set of rules. So we can see here that I won't go into this right away, but these here are the rules. So when you find an A, do this. And when you find a B, do that. And in the beginning, this is where you start from. So it's just saying, start here, there's an A. Once you find that A, do this. Once you find a B, do this. Super simple. And then keep doing it, as you can see, because once it finds a B, it does an A, and then there's another A, it does this again. So that's how it's a growing system. And what he goes on to say here is he goes on to explain this idea of a turtle. And what it is essentially that you can imagine this almost like a turtle that you're giving instructions to, and it's reading them sequentially. So each of these letters stands for something, and this stands for a rule. So in this case, he's saying, okay, he doesn't get there yet, but basically he says, if you find F, tell the turtle to go forward a certain amount and draw a line. If you find a G, tell it to go forward without drawing a line. Turn left, turn right, etc. So what are the rules that this turtle can know, and what are the ones in touchdesigner? Well, you can actually just look up the L system, SOP, in the touchdesigner Wikipedia, and down here it gives you a really helpful turtle operations kind of table of contents. And that's where I started everything. So what I did is I actually copied that into a text document, and then I created a text dat here in touchdesigner, and I pasted it. I got rid of all the spacing, and now I have a little cheat sheet that I can use here, and I can, yeah, just make sure I got everything. Yeah, I do. So now I have my cheat sheet, and now, oh, I just got a notification. Now with that cheat sheet, I can, with that cheat sheet, I can kind of decode this. So let's just take a look. First triple operation, move forward and create a piece of geometry. So the first thing that this thing is going to do is, in our premise, which is our starting state, you go forward 3 times and then do A. So that is represented by, you can see, this part here. This is the three F's. If I remove one of these, you can see it gets shorter. And if I don't have one at all, it doesn't have one. So, G. That's actually a good one. The next one is G, move forward but don't record a vertex. There's also H, which is move forward half a step, like that. So it's saying move forward half a step, then a full step, then do A. Okay, what's A? A is, look at this, we'll go to our thing here, multiply current thickness. I spelled thickness wrong. This is something, this actually inputs, this is really for if you're using a tube here. And what that does is it takes everything that's done here and it multiplies it by this tube scale, the thickness scale. So you can see there, this is basically saying apply the thickness scale. If I were to remove this, then it doesn't apply. Easy as that. What's the next thing? We have a multiply current length. This applies to the, I believe that the step scale size. So if I don't do this, then let's take a look. Then things will continue to grow, but without applying kind of a scale to each one, to each generation. But if I add it, then it does. And say the scale is like that, you can really see. So there's the scale applied. Oops. There's the scale not applied. Okay, let's keep deconstructing. So what is this right here? This here is a push turtle state, start a branch, pop turtle state, end a branch. This one I had to get from a tutorial, one that was actually provided by, what's his name? YXO Delab. Ballad Oxy backwards, that's what it is. He got me. And that is that this is basically starting a branch. So what it's doing is it's saying start a branch here, and in that branch do this, and then end that branch. Do a couple operations, and then create another branch. B, do some more operations, and then do a third B, but not a branch. So what is a branch? It's just a place where the geometry it's constructing breaks off. So in this case, let's see what happens when I just remove this, like that. You can see I no longer have a branch there. Do it again. All I have left is B. So that's what B looks like. Get rid of it. All we have left is nothing. These are kind of like modifier, these are like a little modifier instructions. So you can see here it says roll counterclockwise, so it's twisting. So let's try playing with those. So I'll put in a B branch, got one, and what happens if I add this to behind it? It doesn't do anything because it's happening after the creation of the branch. But if I take it and I put it in front, and you can see at each step, I believe it's each step, it is rolling the creation of B. So let's take those out completely. So I've got B, and if I do another one, if I do a second B, like this, I should have two branches. But how come I don't see two branches? Because they're both in the same spot. So how do we control the movement of these branches, like the positioning in space, how they're angled? Well, there's a bunch of different ones. The biggest ones are, or the simplest ones are the plus sign, which tells it to move in the direction right, and the left one, which says move left, like that. So now we have one branch that's creating a B, that's moving right, and one that's moving left. And you can even stack these up to make them move more left or more right. There we go. Cool. So let's keep going. We have two branches. They're going in different directions. What does the and side mean? The and side sign means pitch up, which I believe is why it's pitching out like that. So if I get rid of that, they go straight up. And the opposite of that would be pitch down. So like that. So I guess down is this way, up is that way. And these can be applied anywhere. So I could say, in this one, let's go right and pitch up. And this one, go right and pitch down, like that. And you can see it kind of looks boring because one is going this way, one's going that way, and it's appearing to make a line. But if we do them both directions, then they'll both go that way. I also don't know if there's any difference if this is before or after. It does look like there is, but that's something that is I don't quite understand. I think it turns one direction before turning the next, but I'm not sure why that makes different shapes. Okay, well here's an interesting thing. We have this guy here. How would we make a mirror of that? Well, this is A, and we can see right now we have HFA. What if we did HF and then made another branch here in our premise that's A. It's the same thing, but what if we did negative A? That's not quite what I wanted. Let's see. There we go. Now we have multiple branches, like that. And remember that this is being limited by our generation number. So we have 7 generations, but if I were to go up straighter, or like, sorry, more, then we would see that yeah, we have more iterations of this rule. I'm going to go back to 7 for a little bit. Okay, so what else we got? F. So every B is saying create 3 line segments, if we shorten these, and then make another A. Okay, so that's the general idea. I think there's a whole bunch of different things here you can apply. Here we have create geometry in different increments. Here we have move forward but don't create increments. But don't create geometry. Sorry, these two. I don't really know what big G means yet. These I'll get to in just a second. Everything else is really interesting and self-explanatory. Another one that's interesting is the tropism vector, which is essentially moving something in the direction of gravity. So if I put the t in there, nothing happens, but if I increase the value of the gravity, then you can see that that affects these branches here. Or I could put it before and affect both. Like that. That actually doesn't make a lot of sense to me. I will have to go back and examine that. But I don't understand it quite yet. What if I put it here? There we go. So now every time it's creating every time it's doing B, it's creating a line, applying the downward vector, which is gravity, and then making an A, which is this, the branches. Okay, let's do one more thing, and that is how to make leaves. So leaves are pretty interesting. All you have to do is plug in a piece of geometry like this. I'm going to make it fewer like that. And I'm going to move the center, the pivot, so that it's on the corner. My cats are going crazy. And then if I plug it into this top one, you can see it's called a leaf input. And we have 3 leaf inputs, those 3. Now, see how it says leaf input J? Now, however, wherever I put in the letter J, it's going to create a leaf. So now it's saying create a line, move it down towards the gravity, create A, and then create a leaf. And then if you scale all these, there you go. So why is there a gap there? It's because of my pivot point. I moved it too far out. Oops. So I move it down back to here. There's no longer a gap. Excellent. Okay, let me do one more thing. What if I want to make a flower? Well, let's just get rid of it. Let's get rid of everything and start from the beginning. So it's quite easy. We'll just construct it slowly. So I'm going to make something that's a bit more petal-shaped, like that. Now, okay, so this is our flower. What are we going to do first? Let's just go straight up. Let's do it again. Let's do it again. And now, we could add some angles to this. So you can see we're twisting here. We could make it bend out a little bit. We could go and make it bend the opposite direction beforehand. Okay, create another F, and now we're going up. Okay, now let's make a new rule. What is that rule going to do? That rule, let's say right now, just say F. Okay, so just doing that. But if we put in J, you can see it creates that one little leaf. And I'm going to scale this up again, like that. I'm sure there's a better way. I'm also going to change the orientation plane so it's correct for what I'm trying to do. There we go. And now, what do I do? How do I make it go into a circle? Well, let's see. First off, I'm going to make this a branch like that, so I could add more things to it. But what if I just rotate it and then make another one? That actually works fine. So now when I duplicate this a whole bunch of times, I'm sure there's a more elegant way to do this. We have a radial symmetry kind of situation. Okay, but that's not actually how flowers are. They don't bend like that. So what if we did an upward vector for each one. So, sorry, or an upward rotation, like that. Take this, and now let's copy it out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. It's actually not 10, it's something else. So now we have this little flower shape. And wherever I put this, so say this is A, let's do something crazy. Let's make another branch. Let's say, okay, B is actually a branch like this that will first turn, and then do this, create 2 lengths, and then make a flower. There we go. And now, this B creates the branch, which creates the flower, and the flower creates the leaves. And that's it. So now if I wanted to add another flower in a different direction, I could do ampersand to change directions, and another B. Oops. Why doesn't that work? What if it's... Huh, I thought that that would just create from down here, because I thought that it would, but I don't think I quite understand it correctly. What if I tried putting it earlier? Like here. Huh. Okay, this creates that. B creates change directions FF. Maybe it's the fact that this is in the actual... There we go. What if, yeah, so this angle was inside of the B, so everything I made went to the same angle. But if I do this, so create a branch where the B is doing that, which is turning inward, then make a second branch where it's turning the opposite direction. There we go. And we're good. So obviously this idea can be expanded over and over and over. We could say, all right, well now let's make C, and C is going to be you know, a whole bunch of stuff. You can just do this infinitely, and it's a really, I found it to be really fun, and I hope that you do as well. There's just so much you can do with it, so much natural stuff you can do with it, and it's really fun to play with, and it's really responsive. And then the best part of it is that when you go back to the LSystem, you can change the generations and you can watch it grow. And that is just so satisfying. Okay, I think it's time to end this. Thank you for watching. Bye.